A very good morning, friends. In today's video tutorial, we are going to discuss Adaline with by taking a solved example of that one. Okay. So our question is, we are going to implement OR function with bipolar inputs and targets using Adaline network. So how we are going to implement OR function in Adaline? See, first of all, what we are going to do is we are going to create a truth table for OR function. You all know the truth table for OR, that is 1 1 is 1, 1 0 is 1, 0 1 is 1, and 0 0 is 0. But here, what we are doing is we are taking bipolar inputs, right? Bipolar input means wherever we are having zeros, they will be replaced with -1. Accordingly, we have taken x1 as input, x2 as input, and this 1 is basically the value of bias that will always have a value 1, and this is our target, that is 1 1 1 1 minus 1 1 minus 1 1 1 and minus 1 minus 1 minus 1. So we have taken this, right? Now you just have to look this specific picture. Here what we are doing, we are taking different epochs. Okay, in first epoch, what we have taken is we have taken all inputs that we have in our function, right? So in this function x1 and x2, we have input this and this, and this is our target. So we have taken this input line from here. So this input line is here, you are seeing this, right? Then we have to calculate the net input that we are representing using yn. So how we calculate net input is we have a formula, yn is equals to bias plus summation of xi times wi, right? So b here is 0.1. We have initially taken these specific values for weights. For w1, for w2, for bias, initial weights are 0.1. So at the first time we are iterating this loop, or for the very first time we are doing the calculation, so we will take the initial values. So 0.1 into 1 will be the value of bias, plus x1 is 1, w1 is again 0.1, x2 is 1, and w2 is again 0.1. So the sum of all these values will be 0.3. So for yn we have the value 0.3 that we have placed over here. Okay, after that we will subtract the value of net input with the target value, that is 1 minus 0.3, that will be 0.7, right? Next thing is we have to calculate the weight changes. Okay, so how are we going to calculate the weight changes? We again have a specific formula for that one. We are representing them using delta w1, delta w2, and delta b, and the formula is alpha times t minus y in x1, alpha times t minus y in x2 for w2, and alpha times t minus y in, we are not multiplying it with any constant value or variable, because b we have seen that it will always be 1, right? So delta w1, what will be the value of delta w1? You will calculate it using alpha's value is 0.1, target is 1 in all these cases, yn is 0.3 in all these cases, x1 is 1, x2 is 1, okay, and alpha is 0.1. So 0.1 plus 0.1 into 0.7 into 1, so you will get 0.7 for the delta w1. Same for delta w2, you will get 0.7, and for delta b you will get 0.7. Okay, so these are the values of delta 1, delta w1, delta w2, and delta b, that is 0.7, 0.7, and 0.07, right? Sorry, it's 0.07 for all these. Okay, after that, when we have computed that how much the weight is going to be changed, we have to calculate new weights, because initially we have taken the initial weights as 0.1, 0.1, and 0.1, and now we have to compute the weight change. Okay, sorry, the new weights after calculating the weight changes. So what will be the value of new weights that we will calculate from here, that we have already discussed? W1 new is W1 old plus delta W1, the weight change. W1 old was initially 0.1 that we have fixed in our as our initial values. So W1 old is 0.1, delta W1 is 0.07. So the new weight for W1 is 0.17. Same for W2, the new weight is 0.17. Same for bias new, we have 0.17. So all these values are 0.17 in this case. Okay, finally, the main important thing is we have to calculate the error in our system. So for finding the error, as we are saying in initial video, that we will calculate the mean square error. So first square error of that one will be t target minus the net input that we have calculated to the power 2, the whole square of that one. That will be 1 minus, and yn is 0.3, that is 0.7, 0.7 to the power 2, 0.49. Okay, now what we are going to do, we are going to take another input line. This is this input line, right? So we will take this input line. Again, we have to calculate y in. Again, we will have to calculate t minus y in. Only thing that you have to take care now is the value of w1, w2 and b will be this value. 0.17, 0.17 and 0.17, because we have already changed it. We have calculated new weights and new bias for them. Same we will do for the third input line, then we will do it for the fourth input line, and once we have completed all input lines for a specific function, we will have to compute the sum of that one, and then we will divide it by total number of elements. That means we are calculating mean of these all errors. So that's why it is called mean square mean errors. Okay, so mean will be calculated by calculating the sum of all these errors divided by total number of elements, and accordingly we will calculate it. We will check that if it is particularly reaching to the specific value of error that we are seeing, that this particular network is going to bear this much error for that specific function. Okay, so it should, in if it is not following or if it is not reaching to that constant value, in that case what we will do, we will move to another epoch and we will again repeat the same process for all input lines, and again we will calculate the mean square error for second epoch, and the second epoch error should be less than the first epoch error. Okay, when we will calculate this, we will see that epoch 1 is having 3.02 and epoch 2 is 1.1938, and same in every epoch it is getting lesser and lesser. Okay, so we will reduce the error and we will try to reach to the minimum error, that is our minimum error point, and once we will reach to that minimum error point or less than of that minimum error point, we will stop the functions. Okay, so guys, in this video we have discussed how we can implement Adaline network in our function. In further videos we will discuss other important concepts of machine learning. So guys, till then please like and subscribe. Thank you very much.